9 different ways of creating a numpy array. When I say numpy array, the data type of a numpy array is np.ndarray. So I'm going to interchangeably use the words numpy array and nd array. So here is a list of 9 different ways in which you can create an array, and all these are methods, inbuilt methods of numpy package. So let's get started. The first method is using np.array, and the parameter that we can pass is, it could be either list or tuple. Now, so first I imported the numpy package here, and then let's say a to be an variable to which I want to save the numpy array, np.array, and if I simply use the square brackets, the empty ones, and try to see what it is, it is a empty numpy array. And let's also see the type of it, the type of this a, and the type of this is numpy.nd array. Now we want to see the dimension also. If you want to see the dimension, there is a property called ndim, which gives the direct dimension of this array. Now instead of an empty list, instead of passing an empty list, let's pass a simple list of 4 elements, and let's see. So here it is a numpy.nd array with dimension 1. And what if, can you create a 2-dimensional array using np.array? Sure. Now here, instead of passing a simple list, if you pass a nested list, okay, if you pass a nested list, so inside this, let's say you're passing a nested list. So let's say this is the nested list I'm interested in, and I'm passing, and let's see what happens. Now a is like this. It's a 2-dimensional array. It has got like 2 rows and 2 columns, 1 2 3 4, and it is of type numpy.nd array and of dimension 2. Now in the beginning I told you you can pass a tuple also, so let me show you that too. B is equal to np.array, and inside this method, the parameters, if I pass an empty tuple, let's say if I pass an empty tuple, then what would I get? I get an 1 second. What is error? B is not defined. B is not defined. Okay. So here what you see is an empty array. Now instead of an empty tuple, if I pass like 1, 2 elements in it, then what will happen? You'll get this. So it does the same thing. Instead of square brackets, if you replace it with the round brackets, all right, it does the same thing. All right, so this is the first method, np.array. Let's go to second method, which is using np.arange. So this is like similar to what we see range function in Python. Okay, in np.arange you have 3 parameters again: start, stop, and step, which the functionality of which is similar to that of a range function parameters, where the start, if whatever the value that put it in the start, it is included, and whatever the value put it in the stop is excluded. Okay, and the step is this jumps that takes from start to 1 less than the stop, that we already know. So let's say I want to like give this np.arange 20. Okay, and another, I want to create another np array, numpy array, with which starts from 20, goes till 0, So, and it decreases at -1. Alright, so first one and second one, let's see what happens here. See, this is first one, this is a numpy array which starts with 0 and goes until 19. The second one is a numpy array which starts at 20 and it decreases by 1, okay, until it reaches 0. And instead of -1, if I put -2, what happens? It starts with 20 and decreases by 2. So this is very familiar as we know Python range function. And if you observe the arange function, the values are not random, they are consecutive. If you say like np.arange 20, it starts with 0, alright, it increments by 1 if there is, because you have not given the step, the default is 1 and it keeps going. Alright, now let's see method number 3, which is linspace, np.linspace. This is a very simple, and you can say like np.linspace, and you can say the parameters are like start from 0, go till 10, or here it is 10.8, so you can give any float value also. And then I want 3 values, so give me 3 values which are equally spaced from 0 to 10.8. And then if you run this, so what you get is 0, 5.4, 10.8. And if you say 0 to 10 and you want 3 values, it would be like what, 0, 5 and 10. It could be, see, you can ask for 30 values from 0 to 10, and it does give 30 values from 0 to 10 which are equally spaced. Okay, this is what is .linspace method, wherein you are generating a numpy array based on the number of values you want between start and stop, or including start and including stop, which are equally spaced. Now moving on, you go to the next method of generating, which is called as np.zeros. np.zeros is simply creating numpy arrays with all elements being 0. Sometimes in certain situations you need to initialize some variables with all zeros, and in that case this np.zeros would be very handy. Now let's see, if we keep np.zeros and pass a single parameter, if we pass a single parameter, you get a one-dimensional array, and we'll see. And if you want a two-dimensional array, you have to pass couple of parameters inside a square bracket, or you have to pass a tuple. So, and the meaning of this is 3 rows and 5 columns, and it is a two-dimensional. So this line, what it says is you are creating a zeros numpy array with 3 rows and 5 columns, which we will see. And if you want a three-dimensional, okay, pass 3 parameters between the rounded braces. So when you do that, this says that you are creating the entire thing. If you see, you're creating a three-dimensional numpy array with 5 rows and 2 columns, and a set of 3 of them. So what I mean to say is, let's run this and see. Now let's see the first one. Okay, you are creating a simply zeros numpy array which is a one-dimensional, and in this you are creating a two-dimensional numpy array, zeros numpy array with 3 rows and 5 columns. So as you can see, it has got 3 rows, right, and 5 columns, 1 2 3 4 5. Now this one might be little confusing. It says like set of 3 with 5 rows and 2 columns, and it is a three-dimensional. So there is a set of 3. This is 1 set, 2 set, 3 set. This is how a multi-dimensional numpy array is created, and you are visualizing or seeing it for the first time. So I'm calling it set of 3 for the convenience. So it creates 3 sets with 5 rows and 2 columns. So that's what it is. 3 sets with 5 rows and 2 columns, right? So this is one of the method of creating zeros numpy arrays. Now similar to np.zeros, we have np.ones. Okay, same, you can pass a single argument or you can pass 2 arguments inside the rounded brackets. We call it as tuple. You can pass the tuple as an argument, and you can pass 3 arguments inside this rounded bracket for a 3D ones numpy array. Now what is ones? So it creates a numpy array with all values 1, similar to np.zeros, which creates all values to 0. Okay, let's run this and see what happens. Now for this one, it produces a one-dimensional array, and for this one it produces 3 rows 5 columns, 3 rows and 5 columns numpy array with all values being 1. And again the same here, which we have seen. How do we read it? Set of 3 with 5 rows and 2 columns, and here we have set of 3 ones numpy array with 5 rows and 2 columns, with 5 rows and 2 columns. So this is again another way of creating numpy arrays. Now let's move to creating identity matrix. So np.eye is a method which creates an identity matrix, and we very much know that identity matrix is a square matrix, all right, and with the diagonal elements being 1 and all other elements being 0. Now what you can do is np.eye, and if you say 3, let's say 3, okay, and I can pass 1 parameter or I can pass 2 parameters, and let's see what happens. Let's run this first. See, when I say np.eye and 3, it created a 3 by 3 matrix with diagonal elements 1, all right, but when I passed 3 comma 5, which means like 3 rows 5 columns, and it is a non-square matrix, right? So how can it be an identity matrix? So the numpy np.eye with 2 parameters does not throw an error, but what it does is it creates a 3 by 3 identity matrix in here, and the rest, whatever extra columns that you have, all the values become 0. That's all. So it is, for convenience, I'm telling it as saying it as identity type matrix, not exactly identity matrix, right? So this is how you create a numpy array, an identity numpy array. Okay, then moving on, we have something called as random.rand, and if you pass couple of parameters, like maybe 2 parameters to be precise, then you get first parameter could be the number of rows and number of columns, and you are creating a numpy array from random values. Okay, let's see what I'm trying to say here. When you say random np.random.rand, np.random.rand, and you say 5 comma 2, that is you are passing 2 parameters, which means that you want a numpy array of 5 rows and 2 columns, 5 rows and 2 columns. You want a numpy array of 5 rows and 2 columns with random values, right? And if you pass only a single parameter, it's going to be a one-dimensional numpy array. So it would be like 1 row, and it would be 3 columns because we are passing 3 here, right? So let's run and see what happens here. Okay, now the first example is, so 5 by 2 is 5 rows. So here 1 2 3 4 5 rows and 2 columns. There are 5 rows and 2 columns. Numpy array is generated, and the second one, if you pass this 3, you get like 1 row at 3 columns, or simply it's flattened array. This is for convenience sake, for understanding and for convenience sake, I have written like this, but it's simply a one-dimensional array or a flattened array, right? So moving on, we have something called as np.random.randn with number of rows and number of columns. Okay, with number of rows and number of columns again, and The only difference is we are adding an n, and because of that, this inbuilt function gives or generates normalized values. What is normalized values? It is same as the standard normal distribution, the bell-shaped curve uh, with mean 0 and standard deviation 1. So all the values are in this range. Okay, so simply you do the same thing as you have done with np.random.rand, and if you see, it is a 5 by 2 random array when you pass 5 comma 2 with 5 rows and 2 columns, and the values are all normalized. And finally, if you see, we have another way of generating a numpy array, which is np.random.randint, with which takes 3 parameters, which is start, the value is included, stop, which is excluded, and the number of values. So what happens is, this np.random.randnd always creates a one-dimensional array. For example, if I say that np.random.randnd 1, 700, 5, what does this mean is I want a one-dimensional array with 5 values, and I want values anywhere, any of the random values from 1 to 699, right? So if we run this, so you get different values. Okay, if I run again it, you get random values from 1 to 699. See, if I run it again, you get randomly generated values from 1 to 699, and how many of them? 5 of them. And what is the dimension of this? This is a one-dimensional numpy array. So this is how you can create all the numpy arrays. So let me quickly summarize everything. So if you use a method got n.array, and if you pass on a list, okay, you can quickly convert a list into a numpy array or create a numpy array. And there is something called as np.arange, which is similar to that of a range function, wherein if you want a consecutive numbers generated, then you can simply say np.arange, and you get a numpy array with all the values. And that is to get which has 3 parameters like start and stop, and if you want like 10 values from this which are equidistant, equally spaced from 25 to 100, you can simply use this method which provides all the values that you are looking for in form of numpy array. And after this, we have something called as np.ones. What we have seen is if you pass a couple of arguments in form of a tuple, then you can generate a 2D array with all ones, which is 2 rows and 4 columns. Okay, you can create a 3D array also with this, with set of 3 with 2 rows and 4 columns. And similar to this, we have seen what is called as zeros, np.zeros. Again, if you pass a single argument, you get a simply a one-dimensional zeros array, and if you pass this inside a tuple with a couple of values, you get a 2-dimensional array. And if you pass 3 arguments, you get set of 2 with 5 by 2, 5 rows and 2 columns, ones numpy array. Then we have seen np.random.rand, and if you pass single value in here, so what you get is a single one-dimensional array with 4 values. All right, 1, 2, 3, 4. Or if you pass like 2 parameters, it gives us 4 by 5 matrix. And if you pass 3 parameters, it gives a set of 4 with 5 by 3 matrix. And now instead of rand, if you put rand n, it does the same thing. But it gives the normalized values. You can this is a 3-dimensional numpy array that we have generated using random.randn. And if you remove this first parameter, then it would be a 2-dimensional numpy array, and you can simply put one parameter and you get one-dimensional array. And finally, np.random.randint is another way of creating a numpy array, and you can pass different values here. Okay, and you know, here what I'm trying to tell, and the output of this is always a single one-dimensional array, and I'm trying to tell that from 12 to 34, okay, randomly pick any value from 12 to 34 and give me 10 values, and or output a numpy array or create a numpy array with 10 values from value ranging from 12 to 34. So all these are randomly generated. So if I run it again, the values are random. If we run it again, the values are random. Okay, so this is how you can generate or create numpy arrays, and the 9 different ways that we have seen.